Hello everyone and welcome back to my channel. Today we will be diving into the world of butterflies using my butterfly prediction model. So let's get into it right away. Here we are. So this is my butterfly classification model, and to give you an introduction, in this project I aim to develop a system that can accurately identify the species of butterflies from images and provide users with informative descriptions about each species. This project utilizes deep learning techniques and image processing to achieve its objectives. Moving on to the next slide is the project overview. In this project, I have gathered a dataset comprising images and textual descriptions for 10 butterfly species. The image dataset consists of 832 images in total, with a distribution ranging from 55 to 100 images per category. These images were collected from Google Images and manually filtered to ensure they depict the butterfly species of interest. Then we have the technical implementation. So to build the butterfly species prediction system, I've employed deep learning techniques using the Keras framework. I utilized the exception model pre-trained on the ImageNet dataset as the base model for the feature extraction and then added additional layers for classification. The system preprocesses the input images, makes predictions using the trained model, and provides users with predicted butterfly species along with informative descriptions about each species. Moving on to the next slide is the workflow of the project. So we firstly have data preparation, which is loading images, pre-processing and splitting into training and testing sets. Then we have model building, which is initializing the exception-based model and adding classification layers. Then we have a very important step, which is the data augmentation, and which is basically to apply rotation augmentation to training data. Then finally, we train the model using the training data and we validate the data on the testing data. We validate the model, my bad. And then we evaluate by plotting training and validation metrics and calculating accuracy. And then finally, we save the model for future use. So that is the workflow. And now we have the user interface. So the components that are there in my user interface are upload button, prediction display label, and description display label. And I've used Tkinter for my graphical user interface. Moving on to the next slide is the conclusion. So the project impact, it can make more appreciation for the butterfly diversities, and it can help people learn more about butterflies, and botanists can use this to work and understand more about butterflies. And for future enhancements, I can improve the model accuracy. Even though the accuracy is pretty good, it has more than 90% accuracy for on the validation. uh, the validation accuracy is more than 90%, which basically means that the unseen data, the prediction on the unseen data is more than 90% accurate. It's a pretty good score, but there's always a room for improvement. And then finally, for the acknowledgements, I want to thank Team Taggle and to all the websites who provided the data. I also want to thank PyCharm for letting me do the code. And yes, so that was my conclusion. And then I have a very famous quote here, which is, and when all the wars are over, a butterfly will still be beautiful. And this is by Ruskin Bond. He's a very famous author. And thank you for going to the presentation with me. Now I will be showing you my code and we will see the project. Here we are. So this is my code to make the model. I've imported NumPy and Pandas, and I've also given the comments. Also, I will be uploading this in my GitHub. I have already uploaded this, but I will be putting the link under my description so that you can also check it out for yourself. Then I have pre-processed the data over here, and I've reshaped the data here. Then I have fit transformed the data. I've trained, test, split the data into training and testing sets. Then I've compiled the model, and I've also used the base model of exception. I've fit the model. I've printed the head of the data frame. Then I've plotted the accuracy and the loss of the model using matplotlib. And then I have printed the classification report. I've predicted over here, and I've saved the model using model.c. Going to my GUI, here I have imported Tkinter because that is what I've used for my GUI. I've used PIL and CV2 for processing the images, and NumPy is for reshaping and things, reshaping the images, and Keras is for loading the model. Here are the 10 butterfly species that I've worked on. These are their descriptions. And then I've pre-processed the image here. I've predicted the butterfly image. Then I have made the Tkinter window. I've added background image. I've labeled the image. I've labeled the program, my bad. And then I've labeled the prediction, the description. I've selected the image, and then I've made a button to select the image. It is pretty basic, but it works well. So you'll see. And this is the final line where you can just run the GUI. So I've already run this before because it takes a lot of time to load sometimes. So here we have the interface, and then let's just upload an image. Let's go with this. There we have. So the predicted butterfly species is Danos plexipus, which is also known as the monarch butterfly. And that is a proper prediction. You can also search it up in Google if you want to make sure. And I've given all my information over here. Let's go with another image. Let's go with this pretty butterfly over here. We have Heliconus charitonius. Proper prediction done. Next, we can just go with this, which also looks like a monarch butterfly a little bit, but it is a Vanessa cardui. So we can see that the model can differentiate it even though both the species look kind of similar, right? So next we can have this white butterfly. There we have Pieris rapi, and we have also the description over here. So we can see that the model is working pretty well, right? And that's all I wanted to show you for my project. And I will be making more classification model videos. And I've already made my playlist, so I will be also adding this video to that playlist. And I hope you enjoyed the video. So stay tuned for more videos. And thank you for watching. Have a great day.